Let's look at chapter 9 then. Page 294. Got the vocabulary on here first. Okay, the diluent, this is an agent that dilutes a substance, a liquid that's added to a powder to change the powder into a liquid, or it could be used to dilute another liquid. So if we're, just diluting it. Sometimes some medicines have a different strengths. Like you might give it in a lot stronger, strength to give it IM versus giving it IV. Because IM, you're going to give it in like 2 milliliters versus IV, you might give it in 50. Graduates containers marked with progressive series or line. If you guys know what like a graduated cylinder is basically what I was talking about. Lyophilized, I'm sure I'm saying that correctly, but that's freeze-dried. Powder displacement, amount of solute that causes displacement in the total volume of medication. And we'll talk about that specifically in a minute, and that'll make more sense. Powder volume, we'll also talk about that in a second. The space occupied by the dry powder or the freeze-dried active ingredient that's related to the total volume of medication after reconstitution. So we'll talk about that in a minute too. Reconstitution is a process of adding fluid, such as distilled water, sterile water for injection, or saline, to a powdered or crystalline form of medication, making it a specific liquid dose strength. And this can be for oral, liquid medicines, or IV medicines. Like amoxicillin, the pink bubblegum medicine. So whenever they get it at the pharmacy, it's like in a big bottle. Well, the bottle that you get it in, but it's already got powder in it. And then you add water to that for, to give out for them to actually take. That's reconstitution, adding that liquid to that. That's all it is. And it's the same for IV medicine. So if you get a vial and it's got powder in it and you add water to it to make it a liquid medicine, that's reconstitution. And then a vehicle is an inert substance in which medication is mixed for administration. So if it's mixed kind of in another area. All right. Okay, 302. And we're going to read a lot of this and then I'll kind of explain it as we go. So we just talked about reconstitution, dissolving the powder medication, that's reconstitution. Let's look at where it says reconstitution of powders into liquid medications. Medications that are unstable in liquid form for extended periods of time are manufactured in either a powder or crystalline form for reconstitution before use. To reconstitute a medication, care must be taken to follow the instructions on the medication label exactly. If you don't follow them exactly, you're not going to get the strength that you need. So they're not going to get the medication amount that they need. Before using the medication, care must be taken that the dry ingredients are completely dissolved or suspended into liquid form by adding a diluent. When used as an injectable medication, single-dose vials or ampules or multi-dose vials are available. Available multi-dose containers are used when a number of doses may be used from the same container within the amount of time that is safe, that is with the safe time limit after reconstitution. So, and they'll usually say, it's good for 12 hours or 24 hours or whatever it is. The diluent used for reconstitution for injectable medications must be sterile and may come in a single-dose vial. As for reconstitution of immunizations that are single doses or in multi-dose vials into sterile water for injection used for multiple doses of antibiotics. To reconstitute injectable medications, sterile syringes are used in the appropriate size for the amount of diluent necessary for the manufacturer's label. So everything stays sterile, because if you're giving it IV or IM, that has to be, then you have to keep that sterile. And single-dose vial, what it's talking about is sometimes you have bigger vials that you can reuse. You put a new needle in, you can draw fluid back out, it's no big deal. Some of them are single dose. It means it's just really meant to be used at one time. Most oral preparations are found in bottles that are larger than the medication volume present. This allows space for shaking the medications before administration. Because the usual vehicle for reconstitution of oral medications is distilled water, graduates are used to measure the quantity of liquid to be added. In some pharmacies, a computerized dispenser for distilled water, such as a Fillmaster electronic pharmaceutical water dispenser, is available. When indicating the correct amount of water to be dispensed, This machine provides 1/2 of the necessary diluent stops and allows time for mixing the powder medication, and then dispenses the remainder of the water on demand. The label on the medication provides the needed information for the necessary volume of diluent to be mixed with the powder to provide the desired dosage per volume. So it'll be right on the label. So that's what we'll practice doing on these. We'll look at the label, it tells you exactly how much. And sometimes it seems like a really weird amount. And that's because you have the space that the medication takes up, and that increases your amount of medicine. So most oral liquid products are described in dosage strengths that indicate the amount of medication in 1 teaspoon of medication, whereas the strength described on injectable products varies with the medication and the manufacturer's instructions based on the intended route of administration. So depending on how you're going to give it may change how much of your diluent you put in there. If the medication is a single strength, single dose vial, the reconstitution is accomplished by adding the amount of diluent indicated on the label. On the other hand, if the medication vial may be prepared at multiple strengths or concentrations, such as found with antibiotics, the diluent must be adjusted to meet the strength necessary for the order. Okay, so they would have to specify how strong they want the medicine to be on the order itself. When reconstituting multiple strength doses, check the label on the vial for the options available for the route desired, and then choose the one that's closest to that of the physician's ordered strength for the intended route of administration. Vials of the same drug may require different volumes and types of diluent for different routes of administration when given parenterally. The directions on the label should be followed exactly to ensure that the correct type and amount of diluent have been used. Some medications may even require specific diluents to be added for IM use, such as small amounts of anesthetics to prevent discomfort with administration. Have you ever had a Rocephin shot? It's a pretty common antibiotic that people get, like they go to the doctor and have a sinus infection. They'll give them 1 shot of Rocephin. It's like burns like fire.
Oh, okay, I haven't.
And a lot of times they mix lidocaine with it. They'll put lidocaine with it to help to kind of numb it. Of course, you give them at the same time, so it still takes lidocaine a few minutes to work. But anyway, I mean, literally, I got one time, and I was like, I need to sit down for a minute and shots don't usually bother me at all. I was like, I should probably sit down for a second because it was just like shooting down my leg. I could feel it. So sometimes that's what it's talking about. Sometimes they'll give something like that. When powders are dissolved in the liquid, the weight or strength of the medication will always remain the same as the amount given on the label. So it's going to tell you, you mix it with X amount of diluent, you're going to have this strength. And that's the one you'll want to be sure that you use. For example, the label for amoxicillin states that the container holds a total of 2.5 grams as a powder. The total weight or strength of the medication will be 2.5 grams after reconstitution has occurred. So it's not going to change the medication strength as far as how much medication it's holding. When medications are supplied in a dry powder crystalline form for stability, the space occupied by the powder is known as powder volume or powder displacement. So that's the space that the powder takes up. The total liquid volume of the medication will be that of the amount of medication plus the amount of the liquid. In the label shown in figure 9.2, the final volume of the bottle is 100 milliliters when reconstituted with 78 milliliters of water. Okay, so look what it says on 9.2 on the next page. Okay, it says tap the bottle until all the powder flows freely. Add approximately 1/3 of the total amount of water for reconstitution. So the total amount of the water for reconstitution, they highlighted it there, is 78 milliliters. So that means by the time you're done mixing with this, you're going to have added 78 milliliters of water. But notice this. See how it says, at the very bottom in big bold letters, it says it's 100 milliliters when reconstituted. It's like right above the green box. Okay? That means after it's mixed, after you've added this 78 milliliters of your water, the total amount of liquid medication that you're going to have is actually 100 milliliters. That's because you have that powder displacement, that space that the powder takes up. So So look, it says, back on that page. So with this reconstitution, the powder volume or displacement is 22 milliliters. So you take your total volume minus how much diluent you put in, and that gives you your powder volume. You just subtract it. So 100 minus 78 is 22 milliliters. That's your powder volume or your powder displacement. Powder volume is the difference between the final volume and the diluent volume. So I'm going to put this up here. Powder volume equals your final volume minus your diluent volume. Put that up there so we'll have it. And if you want to add that, that'd be a good formula to add to your formula, like your conversion chart if you wanted to, so that you've got it accessibly. Okay, so let's look, well, we just did that one. Let's look at example 9.1 here. Okay, it says on the augmentin label, the instructions state to add 1 teaspoon of water for a dose of 125 milligrams per 5 milliliters. On this label, the difference or powder volume would be related to the approximate amount of water added. It says, however, if the label is read as stated, then the powder volume, the final volume is 5 milliliters and the diluent volume is 5 milliliters. So the powder volume equals 0. It says this is not truly correct, as powder volume would be the difference found after adding. There's always a powder volume, but you're going to see some, especially in smaller doses. You know, if you've got very little, like, let's say you're only adding 2 milliliters to make 1 little dose of medicine on a small dose, you're not going to have a ton of powder volume because you have such a tiny amount anyway. That makes sense? So, even though it says it's going to be 0, there really technically is always that little bit, but the less volume you're looking at total, the less that's going to be. It's pretty much zeroed out there. Okay, look at 9.2. Says in this example, the bottle of erythromycin will contain 200 milliliters total. Everybody see at the bottom it says 200 milliliters when mixed. Okay, but look on the instructions. When prepared as directed, each 5 milliliter teaspoon contains erythromycin equivalent to 200 milligrams. Bottle contains erythromycin equivalent to 8 grams. So the whole bottle has 8 grams. And then directions for preparation at the very bottom of that little instructions section. Slowly add 140 milliliters of water and shake vigorously to make 200 milliliters of suspension. So what's our final volume? 200, and our diluent volume is 140. That's how much we're going to add. So we end up with 60 as our powder volume. Okay. Really simple. Main thing that you know is that you can pick out what it's asking you to figure out the formula. That's what I'm, obviously the subtraction is not going to be an issue. Look at, let's see. Okay, we'll do a couple of practice ones. Let's look at number 1 on 306, practice A, problems A. Okay, fluconazole for oral suspension. So we want to know the powder volume. So how much total, what is our final volume, does it say?
No, 35 milliliters.
35 milliliters. It's at the top, kind of on the top right-hand side of it. So 35 milliliters is our final volume, and then how much are we going to mix it with? 24. Yep, on the mixing directions. So what's our powder volume? 11. Yeah. So 11 is our powder volume. Really, really simple. It's really a matter of being able to read the label and figure it out. Now, a couple other things that I do want you to notice, things that you'll be looking for on these labels. Did y'all notice on that last one we read, it said to put in half or a third of the medication first, shake it up, and then add the rest? I think it said that on that, where did it say that? On that amoxicillin in that practice one that we did, it said add approximately 1/3 of the total amount of water for reconstitution, and then shake vigorously, and then you add it again. The reason they do that is, if you guys have ever mixed anything like this before, something's got powder in it, and then I've done this with the formula, mixing a bottle of formula before. If I put the powder in first, and then I add my water, it's like that powder kind of like, yeah, it won't come out because it's like it gels or something at the top, and so it can't get to the dry powder underneath. Do the same thing. So that's why they always say if you'll shake the container first. So like shake it and make sure that all the powder is loose and it's not like stuck at the bottom or stuck somewhere in there. Shake it first, add a little bit of your water, and then shake it again so that it gets mixed up. Then you've got more space in your container to shake, and it will get, it will get dispersed better. Then you can add in the rest of your water and shake it again. That's why they say to do that, because otherwise all that powder gets hung up at the bottom. It's really hard to get it out. So I'll look at the tech note on 306. It says, be aware that medications for IM and IV use are not interchangeable. So just because something you can give it IV doesn't mean you can also give it IM. It'll tell you on the label how it can be given. You can't interchange those. The label on the medication will give, there's some that can be used for both, but it has to specify that. The label on the medication will give its exact use. Some meds will indicate that IM or IV use is acceptable, but will usually show a difference in the amount of diluent to be added. Many medications for IV use may not be given directly from the vial, but require even further dilution in intravenous fluid prior to administration. Sometimes if medicines are really, really strong and they go directly into the vein, they can be really caustic, maybe the word like they can really irritate the vein and kind of almost like kind of burn it because it's so strong. Versus, in the muscle, it takes longer for that medicine to be absorbed, and so it might not do so much damage. It kind of depends on the medication. Some medications are manufactured to be used for only one route of administration. As a pharmacy tech, you make sure that you read the product label closely to be sure the correct route as well as the correct medication and its concentration has been selected for what's prescribed. Says remember that after reconstitution, many of the meds have short expiration dates. Some expire in hours. So, and there's some on here like that Tazocep, the ceftazidime on number 3 there on 307. It says properly reconstituted solutions are stable for 24 hours at room temperature or 7 days if they're refrigerated. So it's good for a week if it's kept in the fridge. And then let's look at number 3. Okay, so that's a good one to practice on. So it kind of tells you up here about the vial, and then you go down here and it gives you the reconstitution instructions. So it's got different ones. Look, for IM use, it's got this little table. For IM or intravenous direct bolus injection, that's like an IV push. If you were to give it like a bolus, means you're giving it all kind of at the same, like at one time. So an IV bolus, like it says right here, injection or direct injection, that's just an IV push. We've learned about that with our abbreviations. You get it in a syringe and you give it over a minute or 2. And then IV infusion is like they'll give it over a longer period of time, 30 minutes or 10 minutes or an hour or whatever. So see how it changes the strength of the medication depending on what you're doing. So it says, what's the powder volume for IM use? So what would it be? Powder volume for IM use.
Good morning, Bulldogs and Delegates. It is Thursday, April 2nd. Happy birthdays. We had one, I think, Monday or Tuesday or Wednesday with Scott.
Okay. Keep going. Where are we on? Number 3. Okay, so powder volume for IM use on number 3, page 307.
that just be 1 gram? Or is that?
No, okay, so we've got our, well, let's find our, this is our formula. So let's find our final volume. What is our final volume for IMU?
Just
3.6.
3.6 milliliters. See the table? See how it's got
Yeah.
vial size, and it has a diluent to be added, and the approximate available volume. So yeah, 3.6. And then our diluent is how much?
3.
30 milliliters.
3 milliliters. So what's our powder volume? 0.6. Good. Okay, so how about for IV infusion at the 1 gram dosage?
Same thing.
Yeah.
Same thing, 0.6. And then what about for 2 grams?
1.2.
1.2 milliliters. Good. Okay, so I wanted you to see how to read that table. Okay, let's go on. 308, basic principles of reconstitution. Think of this as mixing, as the means of mixing a powdered form of chocolate flavoring into a glass of milk. You have the powder and you add the milk a little at a time to prevent the powder from clumping as the liquid is added. The same steps are used with reconstitution. Like I said, tap the vial or the bottle, shake, make sure that the powder is loose before you put in your water or whatever you've got, because that'll help you to get it, to shake it up without it getting all stuck. Make sure you follow the directions exactly. Look at the next tech alert. It says, never assume the directions are the same as previously found on the same medication. Make sure you read the label every time. You know, you don't know. What if they change manufacturers and they manufacture it differently, or maybe somebody ordered the wrong dose or strength of medication or something. So always read it every time. Read it on the label. And never take for granted that you know the type and amount of diluent to be added. Because the amount of diluent will never equal the total volume of reconstituted medication, because the powder occupies some space. And that's, like I said, that example a while ago, it's a really small volume. Sometimes you will see that it will. Let's see. Talked about this ActoVial system, which is, there's a picture of it on 309. It comes with both in like one system, I guess, and then you can, whenever it uses pressure to break that second seal and to mix it. So it already comes with what you need to mix it, like the diluent that you need to mix the medication with. Says this is used a lot with immunizations. Let's see. It says the tech note on 309 says when reconstituting medications with multiple strength, choose the strength that's closest to the order, or that will provide a dose with the least chance for error, kind of like we did in some of the other ones. Now, we practiced getting medicine out of vials before, right? Mm-hmm. Okay. Or at least in here we have. Notice that on here, they show you this picture. Don't forget, one, you always clean the vial. And then the second thing is you have to have that air displacement. And we talked about how you have to push the same amount of air in that you pull back out. Anyways, that's not, I mean, it's the same whenever you're adding a diluent to it. If you're adding 3 milliliters, then you draw back, you know, the best way. But you're going to do this the same way. Okay, you've got to consider your air displacement too. So you have to draw out air first to create that kind of pressure before you put your fluid back in. Anyway. Okay, the person who did the reconstitution at the top of page 311 says needs to add these to, if it holds more than 1 dose. Now, if you're doing a single dose, you don't have to write all this on there. You're just going to draw it up and be done with it. But if you've got multiple doses, then you want to make sure you put your initials, the date and the time when you started it, and then the expiration date, of course, and then the concentration. There's something that's different. Patient Okay, let's look at practice problems B there. Okay, so the total, number 1 on page 311, what is the total dosage of medication found in this container? So the dose of medicine, the dosage of medicine, what's the total amount?
1 gram.
1 gram. Okay. What volume of diluent is added for reconstitution?
5.7.
5.7 milliliters. Oh my gosh, small.
Yeah, last
Yes. Okay, and then what do you use for reconstitution? Sterile water. Sterile water for injection. Good. And then what routes of administration are appropriate? What does it say?
Or IM or IV.
Okay, good.
I didn't see it all. No, here.
Under the actual name of it.
Oh, okay, there you go. Okay. What is the expiration time if it's stored at room temperature?
3 days.
3 days. And then if it's refrigerated, 7 days. Total volume after reconstitution is going to be what?
250 milligrams.
Now your volume.
Oh,
Sometimes you have to multiply these out. I think this one you're going to have to multiply. So look, what does it say? We know the total amount, the total dosage is 1 gram. Now what is the strength going to be? What does it say? The strength as in milligrams per milliliters. That's our strength.
Each 1.5 milliliters, 250.
Good. So the strength is 250 milligrams per 1.5 milliliters. Okay, so it's the same idea. We're going to use our dimensional analysis here. We want to know total volume after. So we want to know milliliters after everything else. We know there's 1.5 milliliters in here, and in every 1.5 milliliters, there's 250 milligrams. In total, this vial holds 1 gram of medicine, which is how many milligrams? Milligram. How many milligrams is 1?
Oh,
Just use your King Henry.
so it's 1 or 100.
1,000. You move it 3 times. Okay? So what do we get? Cross out our milligrams. We got our milliliters left over. This divides into this 4 times. Right, there's 4 doses basically of medicine here. So 4 times 1.5. Yeah. Okay, so 6 milliliters is a total amount that this is going to hold. Y'all see how I got that? Okay. So, and that's an easy way. If I think about 250, I know there's 1,000 milligrams of medicine in there. There's 250 milligrams in each dose. Basically, think of it the way that this says. So it's got 4 doses, so it can multiply 4 times. That's it, you know, to do it in your head. But this works. And this is why I taught you guys this, because this works for so many of the problems that will work out. Okay, good. So some of them you'll have to work out like that. If they don't give the whole amount, you're going to have to work it out. But it's going to give you the strength. And whenever I say strength, that's what you're looking at right here. This is how strong the medicine is. And every 1.5 milliliters, you have 250 milligrams. Okay, what is the total volume? Oh, no, this one we just figured out. 6 milliliters. What volume of medication is given for an order of 750 milligrams every 6 hours IM? So here's where we get into our, I'm going to put our final volume equals 6 milliliters. Okay, so now we've actually got to figure out our dosage here. Okay, our strength is 250 milligrams in 1.5 milliliters. Okay, so how are we going to figure this out? So now our order, what's our order?
750 milligrams every 6 hours.
And we want to know how much is given, we just want to know how much is given for a dose. So how are we going to figure this out? What unit are we wanting to find? Milliliters, because that's how we're going to measure out the medicine and give it to them. Okay, so now what do?
I guess you just multiply by 3.
You could. If I'm doing my dimensional analysis, I'm going to do my milliliters over here. Same thing here, just fill it in. 1.5 milliliters holds 250 milligrams. And I know my dose is, order is for 750 milligrams. Work it out from here. Okay. So I want my milligrams. I got, this is 3. So 3 times 1.5, like you said, should be 4.5 milliliters. Okay. Everybody good with that? Okay. So you kind of got to dig a little bit in there. Thing is, you just need to figure out what units, what are you wanting? So think about this. If it says volume, make sure you're looking for volume. Okay, if it's asking you volume, it's not asking for milligrams. It's asking for milliliters or teaspoons or something along those lines. Okay, so make sure you always go back to the question and say, okay, what is it asking me? What am I really wanting to figure out? Okay, how many vials of medication should be prepared for a 24-hour period if this is their dose? It's going to require a little more multiplication here. So we know 1 dose equals 4.5 milliliters. How many doses are they going to get in a 24-hour time period? 4, right? Because they're getting 1 every 6 hours. Okay, so they're getting 4 doses per day or 4 doses per 24 hours. Then how do we figure out how many vials they need? Okay, so multiply 4.5 because that's every dose. So we need 4 doses. So 4.5 times 4 is what? 18. So we need 18 milliliters, right, total for the 24-hour time period. So then now how many vials do we need?
It contains 1.5, right?
How many vials do we need?
So,
3. See, our vial has
Oh,
6
6,
milliliters. Okay, and as long as we can use it, it says that we can use it for 3 days. So that means they can use the same vial over, that 24 hours or whatever. So that's not a big deal. So 3 vials is what they're going to need for that time period. Does that make sense? Everybody good with that? Takes a little. Sometimes you got to work it out, and so it really helps to write out the information that as you figure it out. So like as we figured out the total volume, write it down somewhere so that you've got that information to pull from as it continues to ask questions. Okay, so write it out. I mean, you'll be writing it out on your answer anyway, but it'll help if you can keep that information organized. Okay, then the last one is, what is the powder volume? Final was 6. What did you add?
5.7.
5.7. So what's your powder volume? 0.3. That's another thing I want to remind you guys. I noticed on some of your answers on your thing is, remember that if you have a decimal, that's your answer. Make sure you put that 0 in front of your decimal. And don't forget to do that. And the same thing, if you have a trailing 0 after the decimal and that's all, don't put that. Just put the whatever your number is. Okay? Just avoids error or risk of error. Okay. Let's do one more of these and then we'll be done. Let's do Well, try to decide which one's going to rank the best. Let's look at number 6. I saw this. Number 6 on page 315. All right, let's write down our info first. Our order is for what?
250 milligrams. of acid.
250. I am TID, which means what? 3 times a day. Okay, so what volume is added to the container for IM use?
3.5 milliliters.
Okay, good. So for IM use, at 3.5 milliliters. Good. So what is the dosage in the container? The dosage.
1 gram.
1 gram. How much medicine is in the container as a whole, the active ingredient? What dosage of medication is found in 1.5 milliliters of reconstituted medication? It's just a random question. I don't know why they asked. So how do we figure this out? What do we need to know first? What?
Mhm.
The strength. Okay, so what's our strength?
Oh, 250 milligrams per milliliter.
Okay, 250 milligrams per 1 milliliter of medication. Okay, so here's our question. It says, what dosage of medication is found in 1.5 milliliters of reconstituted medication? So how am I going to set this up?
1 milliliter that little thing.
Okay, so we're wanting to know, what are we wanting to know?
How many milligrams are in 1.5?
Good, so we want to know how many milligrams are in 1.5. See why it's asking that? Okay, so I'm going to do my dimensional analysis. I want to know milligrams, so I want to make sure my milligrams are on top over here. 250 milligrams in every milliliter, and how many milliliters we want to know? 1.5. So I set that one up. Okay. What do we get? Well, we're multiplying.
Oh, multiply.
Yeah.
Okay.
Milligrams, we worked it out correctly.
Wait, what?
You can use your calculator.
Can you
Just like
multiply
everything.
those two?
Yeah, 1.5 and 250.
Okay. I was thinking.
375.
Okay. 375 milligrams. Okay, there's our answer to that. I don't really know why they asked that, except that they just want you to practice doing that. Okay, now how long would the medication be stable at room temperature? What does it say? 1 hour is it. 1 hour. How long would it be stable in the refrigerator? We don't know. It just says to use it within 1 hour. So that's all we have, regardless of where. You don't want to put stuff in the refrigerator, though, if it doesn't say to put it in the refrigerator, because that can make it crystallize, cause other issues. So it can mess it up. We can't use that. Okay, what is the total number of vials of medication required for a day's supply of this medication?
Just 2.
Let's look at it again. Okay, so how many times a day are they getting it? So 3 doses in a day, right? How much is in 1 dose? 250. What is our volume, our total volume of our medicine? Or our total dosage, we'll say. What's our dosage? Let's say our vial dosage is what I'll call it. How much is in it as a whole? What y'all say?
Was it that one or was it that one?
What's the dosage in the container? What did we say?
1 gram.
1 gram. Okay, which is how many milligrams? 1,000. Okay, so let's look. We're wanting to know how number of vials required for a day's supply. Okay, we don't even have to figure out milliliters here. There's 250 milligrams in every dose. How many doses per day? 3. So 250 times 3 is 750. So that means we need 750 milligrams in a day. Okay, so how many vials would you think we would need in a day?
Yeah.
We would need 1 if we were just doing the medicine. But what's the problem?
Is it reusable?
It's not reusable. Why? Because
Yeah.
because it only lasts for how long?
An hour.
An hour. If we give something 3 times a day, how far apart are we giving it?
Oh,
How often? How many hours?
so 3,
8 hours?
8 hours. Okay. So if it's only good for an hour, once you've mixed it, are we going to be able to reuse the same vial? No. So how many vials are they actually going to need? 3. They're going to have a new vial every time. Does that make sense?
Mhm.
Okay. So that's something to look for. That was kind of a trick question, wasn't it? What volume is given in a single dose? So now you want to know volume given in a single dose. So how do I set up my thing here?
In milliliters.
Uh-huh. This one's going to be pretty easy, but. Okay, so what do I put here? 1 milliliter. We want our milliliters on top, remember, because we got milliliters over here, so make sure we stay on top. Over 250 milligrams, and then our dose is for what?
No.
Our order, I'm sorry.
Oh, 250 milligrams.
Our dose order. Okay. I'm just gonna need 1 milliliter. Is all the dose, okay? How many vials are necessary for a 2-day supply? How many were necessary for a 1-day supply?
3 to 6.
3. So yeah, we need 6. Okay. Well, do you see why we need a new vial for every? Okay. Can all the medication for the day be reconstituted at the same time?
No.
No. Why?
Because it only lasts an hour.
It's only good for an hour. And then what is the powder volume? What do we have to know to get the powder volume?
The final volume and the diluent.
The final volume and the diluent volume. We don't know the final volume yet. What's the, I don't think we do. It doesn't say, does it? Okay. So what's our diluent volume?
3.5.
Okay, we'll come back to that. Let's figure out the final volume. Okay, so what do we know? We know the strength. We know we want our answer to be in milliliters, right? Okay, and our strength is 1 milliliter.
Over 250 milligrams.
Okay, and how much does it say if we're looking at the total vial? We need the final volume. What is our amount of medication we have in the vial? 1,000 milligrams. Okay. What do we get? How many milliliters are in there? 4. Okay. So yeah, so our powder volume is 4 minus 3.5. Lots of steps in these. There's just 10 questions, and chapter 9 won't be due until next Friday. Okay. The chapter 8 is due tomorrow and 7 is due tomorrow, so make sure you get those turned in. If y'all have any questions on those, Just let me know when you're working out. So, but that's a couple things you have to pay attention to is how long is it good for, especially with the vials. You know, when you're trying to figure out how many vials over 24 hours or how many vials over the dose or whatever, that's important to look at.